Hi, it's us again. Now we want to do special angles with radians instead of with degrees.
No, we don't.
So the big thing is you need to get the radian column of your chart filled in. And it's actually pretty much common sense if you do it. And sorry that I have this ugly screen up. I stole it from somewhere. If obviously 0 degrees is going to be 0 radians. Anybody figure out 30 degrees is going to be how many radians? I have people looking at the clock. Think about it. If pi is 180, what do you have to divide by to get 30? 6. Pi divided by 6 is 30 degrees. Okay, 180 divided by what will get you 45? It's a 4. To get 60 degrees, it would be divided by 3, and to get 90 degrees, it would be divided by 2. So you know you have special angles if you have anything that ends with has 0 or it's 6, 4, 3, 2 on the bottom. Okay. We are going to try here to do a special angle real quick. We're obviously, for Heather and Andrew, we had to spend time doing the lovely survey for the pedometer thing, so we are way behind here. But let me try to run one real fast, and maybe you guys can get part of your worksheet done.
No.
If I say to you, do sine of 7 pi over 6, you do the exact same thing you just did yesterday, except you have to think radians. The question is, how do you figure out what quadrant 7 pi over 6 is in?
You don't.
Well, 7/6 is 1 and 1/6, is it not? Okay, 1 pi is where? 1 pi is 1/8. This is 1 pi. So you're going 1 pi and a 1/6 more. A 6, will it be past the halfway line? No. So you will be in the third quadrant. You're at 1 pi and a 1/6 more. Okay. Does anybody remember the really easy way to know your reference angle on these? How much, when I draw this triangle, how much did I go past that? I went past it 1/6. Whatever your bottom number is, that's your reference angle. So this is a pi over 6 reference angle. So all you have to do is go to your chart, find your pi over 6 in your chart, and then come over across to the sine column. Sine of pi over 6 is 1/2. So therefore this is a value of 1/2. And then still do all-star trig class, which would put us in the third quadrant, so it would be negative. Okay. I am going to pause this, but we're back, and for Andrew and Heather's joy, I now have, it's now my planning period, but I have Lily and Naomi who have come to sit here and listen to this anyhow so they get some more problems. So you actually might hear a few voices still going. Aren't they dedicated trig students? So we're going to do a few more radian problems just to get a few more examples on here. So let's do something with a reciprocal. Let's try something like, suppose I asked you for the cotangent of, let's do 2 pi over 3. The key thing usually with radians, the tricky part of radians is to figure out what quadrant you're in. The rest of it's actually usually pretty simple. So you've got to figure out, if this is 2 pi over 3, think of that as 2/3 of pi. If you're at 2/3 of pi, if a whole pi is the 180 line, where's 2/3 of it going to be? Second quadrant, yeah. So you're going to throw your angle into the second quadrant, and then the beauty of doing radians, though, that means now, you know, your reference angle is pi over 3. Since this has got a 3 on the bottom, that's the angle. Makes it a lot easier. Since this is a cotangent, though, we're going to have to go get tangent of pi over 3 off the chart here, and then flip it. So if I flip a square root of 3, I'm going to actually get technically 1 over square root of 3, but you'll have to rationalize that, and that will leave you with square root of 3 over 3. And then what's the other thing you need to check every single time so you don't lose half a point? All-star trig class. We're in the second quadrant with cotangent, and we know that second quadrant is the star, all-star trig class, so I don't think cotangent's in there. So our cotangent would need to be negative. I wrote that wrong. That's supposed to be cosine. I'm going crazy trying to hear. Okay. So there's your quadrants if you need to see them. I want to do one more before we start trying to do one that is combined. So, and I want to do one that, well, actually, I'm not going to say where it lands. I'll just be quiet about that. Suppose we wanted to do the sine of 3 pi over 2. Three halves is the same thing as 1 1/2. So we're going to land if you do exactly 1 1/2 pies. Yeah, because 1 pi is halfway around the circle, and then half of that would land you right down on the 270-degree line. You are sitting on a quadrant line. You'll know you're on a quadrant line with radians. Notice in the table, 0 degrees is 0 radians, or you'll have nothing in your fraction, no denominator. Or if you've got anything with a 2 on the bottom, you'll know you're going to be sitting on a quadrant line. So in this case, we're sitting on the 270, or the pi, it's 3 pi over 2. It's on the same line, though, as pi over 2. It's got a 2 on the bottom. So therefore, when you look up the value in the table, you're going to look up pi over 2. And we're going to need sine of pi over 2 is 1. And then the other question is, how do you decide if it's positive or negative? Are you on the positive side of that axis, or are you on the negative side of that axis? You're on the negative side, so it's going to be -1. So once again, not a lot you can do. The quadrant line ones, they don't have a ton of work to them. It's more of a just kind of look at it deal. Okay, let's do one where we combine several things together. So let's go back to a nicer colored screen. Whoops, but white is not going to work. All right, suppose I said, let's do the cosine of 2 pi over 3, and then let's subtract the secant of pi, and then on the bottom we're going to give it some real pizzazz by doing the cosecant squared of 5 pi over 4 times the tangent of 11 pi over 6. And so you'll have to do each one of those separately and find their values. So I would just start out drawing each one. Where's 2/3 of pi going to be? We just did that one. So we know 2/3 is not a whole pi, but it's more than half, so it's got to be in the second quadrant with a pi over what reference angle?
3.
Yep, pi over 3. So you're going to go to your chart, and you're going to look up the cosine of pi over 3. And the cosine of pi over 3 here is, oops, for these folks here, I didn't fill that in on the board. I probably could pop the chart over. You'll find out cosine of pi over 3 is 1/2, yes. Actually, so that Andrew and Heather can see this, let me go back and just copy and paste this over to the next screen. Unfortunately, it's white, but you can at least get the gist of something. I can see something here. So we got the majority of it. You're missing a few lines. So yeah, if you look up pi over 3 cosine, you're going to see you got a half. Okay, we're in the second quadrant. Is cosine positive or negative in the second quadrant?
Negative.
Negative. Minus, okay, secant of pi. No fraction. No number on the bottom, so that should scream, I'm on the quadrant line. We know pi is the 180 line, so yes, Naomi just said that would be the same thing as 0, and she's right. So we'd actually need to do the secant of 0. So if I want to do the secant of 0, I would need to go, okay, That's the cosine of 0, because it's the reciprocal of cosine. And so cosine at 0 radians, cosine has a value of 1. And then how do you decide your positive or your negative? Pi is on the negative side of the axis, so therefore, since it's on the negative side of the axis, it will be a negative 1. So when we actually get ready to do the math here in a moment, those two negatives really are going to make that a +1. Let's do the bottom, however, first. So if I do the bottom, where's 5/4? That's 1 1/4. So 1 pi is halfway around the circle, and then a fourth more. A fourth of that pi would put us not past the halfway mark, so we're going to be third quadrant, and our reference angle is going to be pi over what? 4. So I need the cosecant of pi over 4. So if I go to the chart, pi over 4, cosecant's the reciprocal of sine, so I need to turn square root of 2 over 2 upside down. And we actually learned today in class when we were playing with some of these earlier that when you flip that over and rationalize it, you'll actually just end up with square root of 2. So we're actually going to get square root of 2. But since it's squared, you will put a square on the outside of that. Technically, we should check the plus or the minus. So technically, we should be going third quadrant, cosecant. It's negative, but since you're going to square it, it really doesn't matter. And then last but not least, 11 pi over 6. That is 1 5/6 of pi. So 1 whole pi is halfway around now. 5/6 more, is that going to be more than half? Yeah, 5/6 is more than half. So we're going to be past the 270 line. We're going to be clear over here in the fourth quadrant somewhere with 5/6. And we know our reference angle is going to be pi over 6 because it's got a 6 on the bottom. So I need the tangent of pi over 6. If I go to my chart, find pi over 6, go over the tangent, we've got that lovely square root of 3 over 3. Positive or negative in the fourth quadrant? Negative, yes. So then last here, where if we combine that, a negative half plus 1 on top, 1 minus a half is a half, so that's pretty easy. Okay, on the bottom, we're going to do a little more work. When I square the square root, that's going to give me 2, and it will become positive, times that negative square root of 3 over 3. So that's actually, when I multiply that together, that's 1/2 divided by a negative 2 times the square root of 3 over 3. Now, how do I deal with a fraction over a fraction? Multiply it by the reciprocal. So I would actually be flipping the bottom one over. And I thought, the 2's will cancel, but nah, they didn't. This is going to end up kind of an ugly answer. So if you multiply straight across, you'll have 3 on top, and on bottom you'll have 4 times the square root of 3. Which, if I rationalize it, will be square root of 3 over what? 12, yeah. The square root of 3 times itself will make 3, times 4 would make that negative 12. Okay, is that simplified? No, it's not, because I can do what? I can reduce the 3 into the 12, and I would have negative square root of 3 over 4. And we just ran a